We are still in section 4.3, and now we're going to talk about standard form for a quadratic function, which is y equals ax squared plus bx plus c. You're used to seeing this probably most frequently using the quadratic formula or when you're factoring. So we can actually find the vertex and all that stuff just by using this form. It's just a little bit different way to do it. To find our line of symmetry, that's the first thing you're usually going to do, even though vertex is going to be listed first. In order to find the vertex, you're already going to do the line of symmetry. So the line of symmetry is x equals the opposite of b divided by 2a. So the opposite of the coefficient of x divided by 2 times the coefficient of x squared. So then to find the vertex, we're going to use opposite b over 2a because the vertex x coordinate is the line of symmetry. And then to find the y coordinate, we're going to plug in opposite b over 2a to find y. Okay. X-intercepts. The X-intercepts, which we also call zeros, roots, etc. What we're going to do is set y equal to 0, or set the equation equal to 0. So 0 equals ax squared plus bx plus c. And then that's going to be a quadratic equation. So we will solve that by either factoring, completing the square, or quadratic formula. We're going to talk about quadratic formula again in a moment. So hold that thought. The x-intercept, remember that it has to be in the form number, comma, 0. Oh, goodness, excuse me. And also remember that there may be 0, 1, or 2 of these x-intercepts. Okay. So regarding these 0, 1, or 2 x-intercepts, with the quadratic formula, we had that thing called the discriminant. The discriminant is the part that's inside the absolute value. So that's the b squared minus 4ac part. So here's our whole quadratic formula. The discriminant is the b squared minus 4ac part. And if our discriminant can actually tell us how many solutions we're going to have. So let's say we have no solutions or no x-intercepts. So we have 0 real roots, because we said there could be 0, 1, or 2. That happens if we're trying to take the square root of a negative number. So if b squared minus 4ac is less than 0, then we'll have 0 real roots. If we have 1 real root, that's when the vertex is sitting right on the x-axis. So 1 real root, or 1 real repeated root. Because technically we have 2 roots there, but they are the same number. And that's going to happen when we have like something plus or minus 0 divided by 2a. So that happens when b squared minus 4ac equals 0. And then 2 real roots. Sometimes they say 2 distinct real roots. Sometimes you'll say hear the word distinct in there. That happens when b squared minus 4ac is greater than 0. So you can use the discriminant to determine, what they say is determine the nature of the solutions. That just means, are there 0, 1, or 2? Are they real? Are they not real, which would be complex or imaginary? Okay. Y-intercept. We're going to do the y-intercept the same exact way that we have always done the y-intercept, and that is that we will sub in 0 for x. And again, when you do that, if I sub in 0 for x, I'll have 0 here, 0 here. So that takes out all of those. So we're actually just going to get this constant term at the end. So the y-intercept is going to be 0, comma, c, the constant term. And then we use the pattern to graph. So remember, our normal pattern is over 1, up 1, over 2, up 4, over 3, up 9. But if we have a stretch, then that's going to be that number out in front, just like it was before. So if we have a stretch or compression, then we are going to multiply all of our ups by that number. And remember that if A is negative, then you're going to turn your ups into downs, because your parabola is going to reflect over the x-axis and it will open down. Domain and range are going to be the same as they were on vertex form. Domain will, of course, always be all real numbers, and the range is going to depend on whether our parabola opens up or opens down. Scared me. Okay, so what had happened is that Mr. Davidson came and banged on the door, and so I paused the video to go see what he needed, and I forgot to unpause it. So I did all of these notes thinking that you could hear me, and you couldn't. So that's cool. So remember that we need to identify if we have standard form or vertex form, because that's going to tell us how we proceed. This one is standard form. So remember that was ax squared plus bx plus c. So we want to start by finding our line of symmetry, which is x equals the opposite of b over 2a. So we got the opposite of 8, which would be negative 8, over 2 times a, so 2 times 2, which makes it negative 8 divided by 4. So x equals 2, negative 2, my bad. And then that's the x coordinate of our vertex. So the line of symmetry is x equals negative 2, and the vertex will be at negative 2, comma, we don't know yet. But to find that y coordinate, we're going to replace all of our x's with negative 2's. So 2 times negative 2 squared plus 8 times negative 2 plus 11. Follow your order of operations. We'll see that we have negative 2 squared is 4, and then times 2 is 8. 8 times negative 2 would be negative 16, and then plus 11. So what I was saying is that you want to check these two numbers. It took me a super long time to figure out what was happening, and that it always happens, that they are going to be opposite signs, these two, and one is going to be twice as big as the other. If that doesn't happen when you're looking for your y-coordinate of your vertex, then you need to go back and look again, because that should be happening. Then we combine that, we get negative 8 plus 11. So my y-coordinate is 3. So my vertex was at negative 2, 3. And we go ahead and graph that ordered pair here, negative 2, 3. Then the regular pattern for a parabola is over 1, up 1, over 2, up 4, over 3, up 9. But then this guy here has a vertical stretch. So this is a vertical stretch of 2. So I multiply all my ups by 2. So then from the vertex, I went over 1 up 2 on both sides, and then back to the vertex, over 2 up 8, which took me slightly off my graph, but that's okay. Next thing I did was find the x-intercepts. So to find the x-intercepts, we're going to set y equal to 0. So we have 0 equals 2x squared plus 8x plus 11. And I already know this isn't going to factor. I can already tell from the graph that there are no real roots. So that's making me suspicious anyway. Because remember over here we had talked about if there's no real roots, that means our discriminant is negative. And I remember that if you have a negative discriminant or the square root of a negative number, we're going to have some i's in there. So I started the quadratic formula. Remember, x equals opposite b, so negative 8 plus or minus the square root of b squared, 64, minus 4 times a, which was 2, times c, which was 11, and then over 2 times a, which gave me negative 64 minus 88, which was negative 24. And that tells me I have no real roots because it was negative. Simplify my radical with the I. Remembered that I had to split these up into 2 different fractions and simplify them each separately. And then what I was saying here is like once you get to this point, I'll give you some time here where you can pause it. Once you get to this point, you have to pay attention to the instructions in the problem. If it says to find the real roots, we would stop here because there's no real roots. If it says to find the complex roots or find all the roots, we'd have to keep going. So if we had to find all the roots or find the complex roots, we'd have to go all the way to the end here and list our complex roots. For the y-intercept, oh, wait, I want to talk about the quadratic formula for a second. Check this out. If I have negative 8 over 2 times 2, that's opposite b over 2a. That's how we find the line of symmetry and the vertex for standard form. But remember also the quadratic formula was this part was opposite b and this part is 2a. So if I take off that part of the quadratic formula, it's the same thing. So really your quadratic formula is finding that line of symmetry, which is like the center of your parabola, and then adding and subtracting the same thing to both sides. So it's finding that center piece and then subtracting and adding the same thing to both sides to give you those 2 symmetry pieces. So just a kind of cool connection. Y-intercept 0c in our function, that was 11, so 0, 11. And we can see that on here, 0, 11. The max and min. This parabola, since it opens up, has a minimum value. Remember that minimum value is the y-coordinate of the vertex. So our minimum is 3. The domain for all the parabolas was all real numbers or negative infinity to infinity. And then the range is going to be related to the vertex. So on ours, we start at 3 and go to infinity.